Welcome to the poster presentation of the Water Reclamation System for Electrolux Fabric Care Reliability Lab project. Team members include Gabe Martinez, Jeremy Tuzizilla, Chandler Horton, Tyler Salisbury, Alex Sineville, Samuel Norval.
For this sustainability-driven project, the design team is working with the Electrolux Fabric Care and Reliability Lab to reduce their heavy water consumption. The project requirements include a target reuse of at least 50%, and the reclaimed water must be free of suspended and dissolved solids as well as detergents.
Our prototype starts at the washer where the water discharges from the washing machine and goes through a pre-treatment filter to capture lint. The water goes through a solenoid valve where it can either be pumped to the sewage or into our gray water tank. Once the float switches dictate enough water is in the tank, the filtration process can begin. To start the process, the rotary vane pump is activated, which will pull water from the gray water tank and push it through the piping and into the unit tester to be filtered. A pressure gauge will be implemented into the piping to ensure the correct pressures are being maintained.
After the gray water has been filtered, any excess gray water will be recirculated back into the gray water holding tank. A needle valve will be used to reduce the high pressures of the gray water recirculation. Once the reclaimed water tank overflow sensor is activated, a pump will be turned on to feed water into the washing machine. A second solenoid valve will be used to input house water into the washing machine to accommodate for any water needed to run a low cycle. The unit tester membrane picked out for this system has a pressure drop of 0.2 bar and a permeant recovery rate of around 8 milliliters per minute.
With respect to the failure mode effect analysis, it has been concluded that the highest priority failures are relating to the cost-driving components such as the primary pump and membrane filtration unit. In addition, any leaks or spillage are ranked just as high to prevent water and electricity from interacting, and also to prevent slippage by any user or employee. Overflow is acceptable as a low priority risk as the system is designed to divert excess water. The cost to produce and assemble this prototype is $4,419.08, driven greatly by the primary pump and unit tester.
This is a visual representation of our system control logic. A minimum water level must be maintained in the gray water tank for the system to reclaim water. The reclaimed water tank must have a maximum water level to reclaim the water back into the washing machine.
To monitor the tank water level, overflow conditions, control the solenoids and pump, and implement the user interface, the STM32 microcontroller and a custom controller board will be used.
After the prototype building phase is completed in Senior Design 2, testing and verification will be conducted in order to obtain data including pressure, flow rates, conductivity, pH, and temperature that will be used to verify the filtration process and scale up calculations.